All right. Well, thanks again, everybody, for joining us today. Again, my name is Travis Jones. I'm one of the application experts here at MLC CAD Systems, and my goal today is to share with you guys basically 7 tools that I think are easy to overlook but offer a lot of functionality inside of SOLIDWORKS. I've been in MLC CAD Systems for 9 years now, but prior to working for MLC, I was actually an MLC customer using SOLIDWORKS as an engineer, just like many of you. And I know that it's really easy to kind of fall into the routine of just using the same tools over and over once you're comfortable with them. So I've kind of come up with this list of tools that I think are just really simple to use, but I think everybody should know kind of how to use them and what they're used for. So there's 7 tools that I want to take a look at, and basically the first one we're going to take a look at is the advanced selection tools. Then we're going to jump into styles, sketch pictures, fit splines, composite curves, modify sketch, and Fillet Expert. So starting off with advanced selection tools, what we're going to do is jump into a large assembly, basically this sorting facility layout. And when we're working with a large top-level assembly like this, and we're trying to get an overall picture of the assembly, a lot of times we want to simplify the configuration of this assembly so that we're not trying to load components into memory or tax our resources for things that we're not actually looking at. And typically this is going to be items like hardware components or very small items that when we're zoomed all the way out we really can't see. And so it's nice to be able to hide those items, with relative ease. Now you could go through your assembly tree and you could find those components and manually hide them. Maybe you've got them grouped into folders like I've got here with a fasteners folder. But even if you do have a pretty organized assembly tree, there's going to be a better way to go in and select components with kind of some automated tools. So if I right click in my graphics area and I look at this top toolbar here, you'll see the mouse cursor with a drop down. These are all of your selection tools. And there's some default ones in here that are pretty good. One that I use a lot is the Select Toolbox option. This will actually go in and select every component that was inserted from the SOLIDWORKS toolbox. But if we've got components that we've received from vendors or suppliers, or maybe they're just common off-the-shelf parts that we kind of manufacture in-house, we might want to add some additional functionality for selecting these items. And that's where we get into the Advanced Select option. So in this particular assembly, what I want to do is I want to select all of my toolbox components, but then I know that this assembly also has a large number of bearings and rollers for that assembly line, and I want to be able to select all of those bearings along with my toolbox components, even though the bearings weren't made from the SOLIDWORKS toolbox. So with this advanced component selection tool, what we get are some kind of logic strings that we can write out. And so this very first one, I'm going to go into the category 1 cell, and I'm going to try and select a component based on its file type. So we're going to select file type for category 1. Under condition, we're going to say that the file type is equal to, and then under the value column, we're going to use the drop down to select toolbox part. And so line 1 will now select every toolbox part in our assembly. But I also need to select those SKF bearings as well. Once we add a second line to our logic here, you'll see that it has an and or condition. So what I'm trying to do here is select any component that is a toolbox component or select any component that is an SKF bearing. And the way that I'm going to select these bearings is under category 1, I'm going to filter based on custom property. Under category 2, I'm going to specify what custom property I want to filter based on, and in this case it's going to be vendor. The condition is going to be equal to, and the value I'm just going to type in, and that will be SKF. So I just happen to know that all of my SKF components in this assembly have a custom property called vendor with a value called SKF. So when I hit apply, this tool will go and select every single toolbox part, and it will select every single SKF component in my assembly. And you can see that it's got a bunch of items highlighted here in my assembly tree now. What I would typically do is go ahead and hide or suppress these to kind of simplify my top-level assembly. But before I do that, what I would encourage you guys to do is right-click on one of those components, and in the right-click menu, go down to the Save Selection option and choose to create a new selection set. Now, selection sets are really, really handy in assemblies because oftentimes you're going to have to go in and select kind of a grouping of components. And rather than have to manually select those every time, what you can do is you can group them into a selection set. That selection set will appear in a folder at the top of your tree. So you can see this one that I just created. And it shows that there are 3,864 components in that selection set. And so I don't care how efficient your tree is organized, there's no way you could have manually selected all of those from different sub-assemblies if you didn't use the advanced selection tools. I mean, you could have selected them, but it wouldn't have been near as efficient. So now, anytime you want to go in and select all of those items, all you have to do is go up here to that selection set. You can right-click on it, and you've got the ability to go in and quickly select all of those items and then either hide them or show them. So keep that in mind. There's a lot that you can do with that advanced selection tool. You can build out all sorts of logic and functionality to really efficiently select a large number of components throughout your top-level assemblies. All right, now we're going to switch gears and we're going to take a look at some drawing tools. And specifically what I want to take a look at is something called styles. So let's say that we've got this drawing that we're finishing out, and we've got a number of different dimensions all over the place, and every dimension's different. It's a pretty good variety. But let's say I go up here to this 1.25" dimension, and I want to add a tolerance. What I'm going to do is I'm going to left-click on that dimension, and you guys are probably familiar with using this property manager over here on the left-hand side if you need to specify things like your tolerance and precision. But another way that you can specify this is if you select a dimension and you look really closely, you'll see that little square that pops up. This is another thing I didn't list on my initial list of features that are often overlooked. But this guy right here, if you move towards it, is called the dimension palette. And it is something that is very easy to overlook. But it offers all the functionality you have in that property manager on the left, but it's right there in the middle of your screen, so you don't have to navigate away from the graphics area. I also like how it's formatted because it's very clean. It's neatly organized. It's compact. You've got text boxes for putting in things like typical values or just custom notes to your dimension. But on the top row, you've also got the option here to add your tolerance. So what I could do is I could specify that we want to add, let's say, a bilateral tolerance to this dimension. And maybe we'll specify that our maximum variation here is going to be something like 0.02, and we'll say that our minimum variation 0.05. Just kind of making something up. All I've got to do is, type in those values, click outside of the dimension palette, and there you go. You can see that we've added that tolerance to our dimension. That works really well for, just creating kind of these one-off tolerances. But what if I wanted to add that in several different locations? Maybe that's kind of this standard tolerance that we add to certain feature types or geometry, and I want to add that same tolerance to other dimensions. Well, there's really kind of two ways that you can approach this. One way is that you can simply just go click on another dimension, and if you go back to that dimension palette, in the top right corner of the dimension palette, you'll see the blue star, which is for styles. And styles are a way for you to kind of capture a customization or a standardization to an annotation that you've created. So under that styles dropdown, you'll see here that I've got a list of recently used tolerances. So I could go and select that previous tolerance right here of maximum variation 0.02, minimum 0.05, and it will actually apply that same style to this dimension. You'll actually see that it puts the parentheses around it as well. So it basically copies that same exact format that we had created for a previous dimension, and it just copies and pastes it over to another dimension elsewhere. There's another way that you can use styles. If you click on one of these dimensions that you've customized with a tolerance or any other change, and you look at that property manager over on the left, there is also a group here for styles. And you'll notice that you get a few more options, one of which is to save a style. So what I could do here is I could say that I want to add or update a style, and it's going to let me add a name to this. So what I could say is just something like standard tall. Maybe this is just going to be my standard tolerance, or anytime I need to actually call out a specific tolerance, this is what I want it to be. So once I've added that new style, let's say that I want to go create a new dimension. I grab my Smart Dimension tool, and I'm just going to go add a dimension over here to this bottom edge. And if I want to use that same exact style, what I can do is just go to the drop down in the Property Manager, and you'll see under the drop down for styles, that standard tolerance is now visible. And all I've got to do is select it, and it quickly applies those same values. What's cool about this as well is you can actually share these styles with your coworkers or easily move them over to another machine where they can be reused. If you hit the Save Style option, it allows you to save out that style with a name, and it actually has its own file extension. You can put these on a shared network drive, you can put them in SOLIDWORKS PDM, or you can just copy them to other users' computers, and everybody will have that same standardized tolerance, and you can quickly go and kind of reuse those styles to save quite a bit of time. There are several places inside of SOLIDWORKS where you will see styles. I'm not going to go through all of them, but some other common places would be things like weld symbols. So if you take the time to go build out, say, an ANSI weld symbol, and you fill out all these different parameters, you'll see in the bottom right that again you have the option to save that as a style. Same thing with surface finishes. If you go and you spec out a surface finish callout, you can also save a style for that as well. So just kind of keep an eye out throughout the software. There are several places where styles will appear, and anywhere that they appear, you can pretty much bet that it is worth it to go ahead and save that style and be able to reuse it later on. All right, moving on from here, we're going to take a look at sketch pictures. And for this, I'm actually just going to go ahead and start a brand new file. And what I'm going to do is I'm going to create a sketch right here on the front plane. Oftentimes, if you're trying to prototype something, or it's kind of just that initial design, it's helpful to have a picture to work off of. And this could be something as simple as kind of just a sketched out item on a piece of paper that somebody took a picture of. It could be a picture of an actual item that you saw out in the real world and you snapped a picture of it. Now you want to try and model that item. But a picture makes a great reference. And if you're in a sketch, you can go and insert a sketch picture just by using the sketch picture tool. So I'm just going to snag that from my search bar here. I'm going to browse to the picture I want to use, and in this case, it's the body of a guitar. And what you'll see is once I select that image, it's going to go ahead and import that image into my sketch. You may have seen this tool before, but there's a couple of things I want to show you that can make it a little bit easier to use. And the first one is the ability to scale. So you'll see that on the left-hand side, you do have options for like the X and Y dimensions. You can essentially use those to position and scale this item, but sometimes it's easier to use the scale tool that you see out here in the graphics area. That's going to be that blue bar that's kind of running horizontally through the center of that guitar body. The way that this scale tool works is that you place the base and the tip of that scale tool on 2 points that you have a known dimension between. So let's say that I know the distance from the left hand to the right hand side of the guitar as it sits right now. I'm going to drag this scale tool to the left hand side, and then I'm going to grab the right hand side of that scale tool, and you'll see that it actually expands to make it a little bit longer, and I'm just going to place the point of that scale tool right on the edge of that guitar. And as soon as I place that point, you're going to see that modify dialog box pop up, and it's going to ask me to input whatever this distance should be. Now, let's say this body is something like, I don't know, we'll say 22.5 inches from left to right as we see it now. Whenever I hit enter, it's going to go ahead and scale it accordingly, and it's going to shrink down that whole image based on that scale factor. So it makes it really easy to just kind of snap a picture. All you've got to do is have one known dimension, and then you can use that scale tool to lay it across that known dimension and just type in the value accordingly. From here, what I'll typically do is I will just take that image and I'll reposition it relative to the origin. All right, we'll hit fit to screen to get everything centered back up. And once we've kind of got the origin and the sketch picture oriented how we like, the last thing that I'm going to look at as far as the sketch picture is transparency. So you can kind of see that white background around the guitar body. It's not a huge issue, but sometimes we don't want that extra border around the image. If you have a really clean background, you can actually create your own transparency relatively easily. This picture is actually not even that great. There is a little bit of a gradient around the edge of the guitar. But if I go to the left-hand side and I choose the option under transparency for user defined, you're going to see that it gives me the eyedropper tool. And all it's asking me to do is actually go click on the background of my image, and it's basically taking a color sample. So you'll see it populates the box over here on the left with the color of the background. And then I'm just going to take this matching tolerance and transparency slider and ramp them up, and you'll actually see how that background starts to disappear. Right, so see as I go back the other way how it turns white, and then it starts to actually turn transparent as I move all the way to the right. Now, it's not perfect like I said in this image, but it does get rid of probably 90% of that background, which is going to make it easier as I start to move forward with this model. I'll be able to see, to the other side of this sketch picture. It won't be blocking everything behind it. I'll hit the green check mark to exit out of the picture editing mode, and now I'm still in sketch mode, which means I have the ability to go and maybe trace this guitar body. So one of the things that I want to do is I want to trace this contour around the top side of this guitar. And typically the way I would do this is with a spline. Now splines can be a little tricky if you've never worked with them before. Generally what you want to do is place a control point everywhere that there's an inflection in the curvature. So kind of think of like high points and low points. That's usually a good starting point for trying to work with a spline. And then generally you can modify it from there to kind of tweak the appearance. So if I use these control points, not too bad. Now, that being said, some people just find it a lot easier to work with things like lines and arcs. So what if I started creating this profile with lines and arcs instead? Well, I could create straight lines to approximate some of these edges that are a little flatter, and then I could transition into a series of arcs. It may not be the most efficient method, but the nice thing about lines and arcs is that they're very easy to dimension. Splines are quite difficult to dimension. They have continuously changing curvature, which can kind of make things a little bit tricky if you're trying to be exact about the radius you're placing. And so by creating these arcs, when I go to dimension, I could actually make some pretty precise dimensions for the curvature of this body. Now, that looks pretty good, but the kind of area where this has its pitfalls is if I were to go create, let's say, a surface using that series of lines and arcs. If I do an extruded surface, what we're going to see is that it's not just one continuous surface, it's actually several different faces kind of making up this one surface body. So you'll see how I can make these individual selections here. And while that's not necessarily a deal breaker, it can make things a little bit more complicated later on when we start to do things like trims and knits and try to get this watertight body. It's just more surfaces to deal with. So what I'd like to do instead is maybe take that geometry I created but convert it into a spline using something called a fit spline. If I go back and edit that sketch, what I can do is in my search bar I can type in fit spline. And this fit spline tool allows me to select what we would call standard analytical geometry, things like lines and arcs, or rather algebraic geometry. And it's going to convert that into a spline that really closely approximates the original geometry. So I'm going to select that chain of lines and arcs. I'm going to uncheck the option on the left that says close spline. So that'll just give me just an open loop. And the other options that you have here are whether or not you want to delete the original geometry or keep it there as construction geometry. And then you also have a tolerance slider that determines how tightly you want your spline to fit to the original geometry. Now, once you're done, it's going to replace that series of lines and arcs with a continuous spline. And where that kind of pays off is if we go look at our surface now, you'll see that it's one continuous surface. We don't have any boundaries within that surface, and that could make things a lot easier for us downstream when we start to merge additional surfaces or do things like trims and cuts. So keep that fit spline option in mind. It definitely lets you work with simpler sketch tools and then convert them to a spline once you're ready. and it can give you some really robust surface bodies with relative ease. All right, so kind of sticking with that same theme where we were looking to take several different geometric entities and kind of combine them into one. The next thing that we're going to look at is something called compound curves. And the reason we're going to look at this is because we want to create a spring, and what we're going to do is we're going to create a spring that has this helical coil, and then at the end of that spring what I want is to have a little bit of a hook. Now that hook presents a little bit of a problem because it's actually going to curve in two directions. If we're looking at the hook from the side, what I want it to do is kind of create this this U shape that we see here. And then from the other direction, we look at it from the end, I want it to curve like we see here in this kind of semicircle shape. So it's going to actually curve in multiple directions. Now in order to accomplish this, we use something called an intersection curve. If you've never seen one of these before, basically you go up to Insert, Curve. Sorry, I said intersection, it's projected curve. We're going to choose Insert Curve, Projected Curve, and then we're going to select both of these sketches. And you'll see that it basically projects both of those curves, and it creates a curve where the two curves would actually intersect with one another. And the result is a really pretty looking curve that you see here. Now the reason that this is a little bit of a problem is because my goal is to actually sweep a circular cross-section along the entire length of both this helical spiral and this projected curve that we created. And you'll actually see that that's not possible right out of the box with a sweep tool. If I create a sweep with a circular profile of 0.5 millimeter, and then I go to select the path for my sweep, it'll let me select one of these curves, but it won't necessarily let me select both of these curves. Even if I try to use the selection manager, and I say select multiple, it'll only let me select one of the two curves. And that's because if you're using these complex curves, the sweep wants one continuous complex curve. The way that we get around this is with a tool that I think everybody should know how to use, and that's going to be up here under Insert Curve. It's called Composite Curve. With a composite curve, you can simply join two entities. So in this case, I can select both of these curves, and it will join them into a single continuous curve. Now what I can do is under my sweep tool, I can select again my circular profile option, and then we'll go ahead and specify our circular cross section. The diameter is just going to be 0.5 millimeter, and you'll see that it's able to complete that sweep along that continuous composite curve. So this is a great way to create very complex sweep paths. You can use several different tools. In this case, we used a helix, we used a projected curve, and then we combined those with a composite curve, and that really simplified kind of our design process for creating this really neat spring. The next thing that I want to take a look at is I want to go ahead and look at the Modify Sketch tool. So let's say that we're creating a sketch in SOLIDWORKS, and what we want to do is we want to take this sketch that we've already created and we want to copy a sketch to a different sketch plane. Well, there's several different ways that you can copy sketches in SOLIDWORKS, but in this case, I'm just going to select the sketch from my feature tree, hit Control-C to copy. I'm going to select the plane that I want to copy it to. So in this case, maybe I'll just go ahead and select the right plane, and then I will go ahead and paste it with Control-V. And you can see that it was easily able to copy that over. Now, that's easy enough, but what if I need to manipulate that sketch further once it's been added to this new sketch plane? Well, for that, I can actually go in and edit the sketch, and then in my search bar, I'm just going to go ahead and type in the word Modify to bring up the Modify Sketch tool. This Modify Sketch tool has a lot of really cool options. It'll let you scale the sketch either around the sketch origin or around an origin that you specify. So if you need to make things a little bit larger, it's pretty easy. You can also translate it or rotate it, but there's kind of a little, I guess, hidden entity in here that you have to look for or know that it exists in order to be able to use it. So if you look out in the graphics area, you're going to see this little L shape here and this is more or less an XY coordinate system. And what I'm going to do is I'm going to drag that to a specific point, like let's say down here on my actual sketch origin, and I'm going to drop it in. Now, that little triad, or that XY coordinate system rather, you'll see that it has 3 points on it. And if you look really closely, you'll see that my mouse cursor changes a little bit as I move over those different points. And that's because each point serves a different function. If I move to this bottom right point, and I right-click on that point, you'll see that it actually mirrors or flips that sketch across that point. So basically across my vertical axis. Likewise, if I go up to the top point in that little XY coordinate system and I right-click on the point at the top, it will mirror it across the other way. So it's a really neat tool that allows you guys to kind of manipulate sketches in their entirety. I use this a lot whenever I copy a sketch to a new sketch plane. This might be for doing something like a loft or a boundary where I've got several different sections that are going to vary slightly. That tool is great for being able to mirror and rotate and flip and scale and do all sorts of neat things to hopefully save quite a bit of time as you manipulate that sketch profile. And let's go ahead and jump into another part. The very last thing that I'm going to show you guys today is Fillet Expert. And if you've never seen Fillet Expert before, Fillet Expert can do quite a bit, but there's really just one simple thing I want you to know about Fillet Expert because it can help get you out of some tricky situations. Let's say that I'm trying to apply fillets to the part that we see here. And what I want to do is I want to apply a 2mm fillet across several different edges in the bottom of this part where we see this boss extrude. So maybe I want to fillet 2mm along that interior corner, and then I want to also fillet across the top of that boss extrude. Well, as soon as I click on this top edge, you'll see that the preview disappears. And that's because there isn't enough geometry to execute both of those fillets simultaneously. That wall height right there is really only 2mm tall. And so if you've got two fillets that are both 2mm, they would overlap. And that essentially means that one of those fillets has to execute before the other. So if I hit the green check mark right now, you'll see that nothing happens. It basically throws a big error saying this isn't going to work. And this is really what I want you to know about, is if you go to the top of that fillet property window and you go to Fillet Expert, like I said, this tool can do quite a bit, but the best thing, or at least the most important thing that I think you guys should be aware of, is that it can help order these fillets in a way that will actually work. So if I just go ahead and select 2mm again for my fillet radius and then select those same 4 edges across this boss extrude, my preview isn't visible, but if I hit the apply button, you'll see that this little Fillet Expert progress bar appears, and then it is actually able to create those fillets. And what it's doing is it's going in and trying to see if it can break up this one fillet feature into several fillet features so that we have an order of operations for which fillets get created in which order. Once it's done, if I hit the green check mark, you'll actually see at the bottom of the tree here that even though I really only intended to create one fillet feature, it went ahead and it broke it up into 4 different fillet features and found that there was a way to execute these in a specific order to make them happen. So I use this all the time to get myself out of a tricky situation. You do give a little bit of control up because you don't necessarily know which order that Fillet Expert tool is going to create those fillets in. You do have the ability to reorder them later on, but more than anything, I think this is just a great way to save yourself from having a big headache. If you've got a complex region that you're trying to fillet and you just want to know if it's possible depending on the order of operations, try out Fillet Expert. I think it's something that's great for kind of helping you get out of a jam. So I hope you guys enjoyed taking a look at these 7 different tools. Like I said, I know these tools are fairly simple. There's nothing too crazy about any one of them, but I think I've just found over the years, knowing that those tools exist, knowing when they can be used, they're very, very efficient. They're easy to miss if you're not looking for them. And so I hope that you guys can kind of take that with you and start to use those tools to make your design process more efficient.